Greetings! My name is Kathy, and I'm with the Friends of Arlington's David M. Brown Planetarium. I'm pleased that you can join us today. We are going to talk about early astronomers today. We're really pleased to have Dr. Sethanne Howard back with us again to talk with us about early astronomers and early astronomy. One note before we get started, the David M. Brown Planetarium in Arlington, Virginia is still closed because of a construction project, but the good news is it is scheduled to reopen later this year, and the Arlington School Board has indeed recently approved funding to get a new projector. So hopefully we will reopen with a new state-of-the-art planetarium projection system. So that's exciting news, and we'll have more on that later. We're recording this in February of 2022. But without further ado, I'm going to leave this to Dr. Sethanne Howard. And Sethanne, please take it away.
Okay, go ahead and show the PowerPoint.
And you're there.
We're there, the people of early astronomy, and this is Sethanne Howard. I'm going to show you me in a second, but first of all, we're going to do just the title, and I'm told by people who do these things that you have to have a joke. So here's my joke. Everybody prepared? Astronomers are star-craving mad. But that's not a big joke, but it's a little joke. And I thought I'd show you what early astronomers 4,000, 5,000 years ago would see in the sky. This is a view of the sky as seen from the desert, and the Milky Way is draped across the sky. I think it's a very impressive picture. It's taken in Death Valley, actually, in California, but it's the desert, and it's what you see in the desert, and it's just gorgeous. So I am Sethanne Howard. I'm retired from the U.S. Naval Observatory as Chief of the Nautical Almanac Office, and I'm an astronomer. And to my right on the slide, it's Urania, the muse of astronomy. So I thought that was appropriate for this talk. The two main civilizations that we're going to begin with are Sumer, it's marked in a little blue rectangle, and Egypt, marked in a little blue rectangle. Sumer is in the, if I can move my, this is the Tigris and Euphrates rivers. Mesopotamia is between the rivers. That's what the word means. And this is the Fertile Crescent, 4,000 years ago. And we'll start with Egypt and Sumer as the main kingdoms that we'll work with, because they were the earliest civilizations in human history, with one exception. And the one exception is the Indus Valley. And that is between India and Pakistan. And I'm not going to talk about it because we have not translated anything from the Indus Valley. We know that they were very sophisticated people, but we don't know anything about them because we can't translate their writings. So to go back to the detailed part of the Fertile Crescent, here is the Euphrates. Here is the Tigris going up there. And I point out that 4,000 years ago, the Persian Gulf came up this far. Today, the Persian Gulf has filled in land down to this blue line down here, if you can see my pointer. So Sumer is the lower part of the Mesopotamia. Elam is the Proto-Persian part of the world, early Persians. And Akkad, is the northern part of the Fertile Crescent. And the Akkadians in 4,000, 3,000, or really 2,000 BCE, 4,000 years ago, had conquered Sumer. So they had conquered all of Sumer. Sargon who was the king of Akkad at the time, conquered Sumer. And so this is we're going to start with the city of Ur, and I've marked it with a white arrow. And Ur was a port city. Very, very important, because they would import things from all over the world. They'd bring them up by ship into the Persian Gulf, and that was part of the major trade center in that area of the world. But just for fun, I thought I'd show you where Babylon is, because later in history, Babylon becomes important. And this is Iraq today. These are near Baghdad, Iraq. Elam is Persia, Iran. Now, we need writing in order to talk about people, because if we don't have a writing from them or something that tells their story, we don't know about them. They could be legendary. Writing began in Mesopotamia. Shortly later, it started in Egypt with hieroglyphs, Mesopotamia in cuneiform, the Proto-Persian, Elam. Those have never been translated, that language, the Elam cuneiform. But we've translated Mesopotamian cuneiform. We've translated Egyptian. We've translated Linear B, not Linear A, but Linear B, and Crete. And our English language came via Syria and Palestine through the Phoenician alphabet with the Greeks. But I point out that China, the first writings of China were around 1200 BCE. They came later. They wrote about stories from earlier times, but the actual writing was 1200. That's the earliest writing. So the earliest astronomy in legend is Imhotep. Imhotep is supposedly, according to legend, designed as the architect of the first pyramid, the step pyramid in Saqqara, Egypt. And in order to do that, he had to use astronomy because it was surveying, and it was all done with the stars. So according to history, he may have been real. He may have been a conglomeration of people. They don't know. So he's kind of legendary. That there was somebody who designed the first pyramid, but we don't know if it was Imhotep or not. But I put him down and I circle him in blue or white to indicate that he is legendary. Sumer is where we'll really start, because in Sumer, so the Sumerians, in case you didn't know, that's where they invented the wheel. I don't know who invented the wheel, but they invented the wheel in Sumer, according to historians. The first examples of writing are from Sumeria, cuneiform. They studied in class. They had students in class, schools, reading in math and astronomy. They developed the lunar calendar. I'll talk about that in a little bit. And according to historians, this is the beginning of modern science in Sumer and the beginning of modern history. There are people who disagree with this. The people who disagree with this are some philosophers who say that modern science didn't start until the Greeks. I disagree with them. I think modern science started back in Sumer when they taught math and astronomy and reading and invented the wheel. And we need writing as an example of the only way to find out about these people. And just as a curiosity, this is a lunar month, 29.5 days. To make a lunar calendar, you have 12 lunar months. It doesn't match the solar calendar, but 12 lunar months is a few days short of the solar calendar. And if you have to teach the solar calendar to phases of the moon to your kids, why not use Oreo cookies? the head of the student would be right in the middle so they can eat any cookie they want. And you can show the phases of the moon in Oreo cookies. I thought that was cute. Now, timekeeping and calendars was important all throughout history for astronomers. It was the main job security for astronomers. In fact, the 4,000 years ago, the megalith chamber tomb in Newgrange, Ireland, still shows the winter solstice on the winter solstice. It lights up the chamber of the tomb. And so I've marked the place down the column and what happened across the row. What I really want to talk about is China. China, as I said, was 1200 when it really started writing, but they wrote about their history. And in their history, in 2136, there was a solar eclipse. And a solar eclipse is a big deal. The dragon is going to eat the sun, and you have to beat your drums and chase away the dragon. So the court astronomers, whose names are there, He and Ho, were supposed to announce the upcoming solar eclipse to the emperor. They weren't there. They didn't announce the solar eclipse. It turns out that they were drunk on rice wine and asleep. And the eclipse came. The emperor was very annoyed because they got an eclipse with a no warning, and they quickly had to get the drums out and chase the dragon away. But he beheaded the two astronomers. So keeping your time correctly is important to keeping your head. He and Ho lost their heads. That's what happens to astronomers who don't do their calendars correctly. And throughout time, calendar keeping remained through history and down to the Arabs, who in the golden age of Arabic science, in the years around 1000, that was very important, getting the calendar right. So the earliest astronomy, maybe Imhotep, maybe not, and then we're going to have real people. We're going to leave the legendary behind, and there's Hatshepsut, a pharaoh of Egypt, Moses, the Trojan War. These are things just to give you a feeling of what was going on during the time. And my personal favorite was the introduction of chocolate to the world in 1100 BCE. And the first Olympics were held in 766. And the year of the founding of the city of Rome was 648. So this is the earliest astronomy. That was the cat who did a thud and a meow. Who I'm going to come in after the legendary and ahead of the reality. I'm going to come in around 2300 BCE with the first astronomer I know of. Imhotep might have been, but we don't know. I'm going to come in there. So that this first astronomer was 4,400 years ago. Her name was Enheduanna. It's in Sumerian. She was in Sumer. She was in Ur, the city of Ur. And she was the chief, or En is an honorific, astronomer priestess of Ur. 2334 BCE is when she lived. And she wrote the following, which I found interesting. Something has been created that no one has created before. And that tells me that they did indeed probably invent the wheel. She was talking about things like that. We have her picture, sort of. This is an alabaster disc about half a yard in diameter. in the University of Pennsylvania Museum, and it shows her in procession. And it talks about the procession on the side of the disc over here. And we think it is her procession as appointment, her appointing her as chief astronomer priestess of the city of Ur. She is dressed in the outfit of the chief astronomer priestess, and it's not silky. It looks like it might be silky layers, but those are actually ram skin. They're stiff and awkward to walk around in. They're made of ram skin. We know where she lived. She lived in a building, a garden building named Gipar. And I show you an overview of video, upper video of the archaeological dig at Ur. This is an aerial view. And in it is a ziggurat. That's the ziggurat. Now, the ziggurat in Ur was created after her time, but I put it in because it's the most famous one there is, and everybody knows about it. If you go to Ur's dig site, archaeological dig site, there it is from the side. This is a schematic of the ziggurat. And to give you a sense of the scale, here is a picture, a photograph of a ziggurat with an army Sherpa aircraft flying over it, just above it. So they were huge things, but she lived by the side of it in the Gipar. It wasn't built during her time. It was built after her time. She was one of the primary advocates of astronomy and mathematics in Ur. She codified it. And the Sumerians used base 60 math, which is why we still today have 60 seconds to the minute, 60 minutes to the hour, and 360 degrees in a circle. That's from the Sumerians, and it was from the time of Ahenuana. She, along with her cohorts, created a network of observatories to view the stars, planets, and the moon and record their motion. So we know they did that. They recorded the moon, phases of the moon. She helped define one of the first calendars, which is a lunar calendar, which is still in use today to date religious events. And a lunar calendar, as she defined it, each new moon was announced by the head astronomer priestess, each new moon of the month. And that group of priestesses who announced the new moon were called the synod. Hence, the lunar month is the synodic month. That's where the term comes from. The synod, the group of people who announced the new moon. We have her writing on tablets, actually real tablets, and this is her name in Sumerian script. The writing is done on damp clay with a reed taken from a nearby stream, a hollow reed, and they would press it into the soft clay and make a mark. And that's the writing on tablets. Now, my generation, which is a little bit older than your generation, we grew up with the 10 Commandments and Cecil DeMille and the 10 Commandments movie. And so to us, tablets meant this: huge things that were not many words on them. That's not right. That's not what they look like. They look like this. She was known as the Shakespeare of the ancient world because she wrote so much stuff, and the world's first poet, because when they wrote in poetry, everybody. 2 long poems and 42 short poems of hers have been translated into English, and you can find them on the web. This is what one looks like. It's got 2 columns. Right down the middle is separating them. This is a column, this is a column, and it's writing on both sides of the tablet, not just one side, but both sides. This has got cracks in it, but they wouldn't, when they showed it to me in the museum, they wouldn't let me have it, which I thought was too bad. At any rate, this is her famous Hymn to Inanna tablet. Inanna was the goddess of the moon, and she starts out this way in describing Inanna and as the world's first poet. But you can find a lot of her poetry translated by other people in books. So she wrote a lot. This is a sample of the size. It's about the size of a large cell phone. Both sides were written on, and you can see, you can see the division down here. And they'd write down one side, then they'd write down the other side, then they'd write on the other side. Her writings were so influential that they were studied for millennia after her death. And you can find her style all the way through the religious compositions of the time into the early Christian church, which I find amazing. That's 2,000 years of influence of how she did prayer and petitions to the gods and goddesses. This is a translation from one of her poems, one of her short poems, that tells me she was a scientist. She calls herself the true woman who possesses exceeding wisdom. She consults a tablet of lapis lazuli, which was very rare. She gives advice to all the lands. That's a leader. She measures off the heavens. That's an astronomer. She places the measuring cords on the earth. That's a surveyor, a mathematician. So that tells me she was a scientist because she measured off the heavens. Another poem that she wrote says, in the Gipar, which is where they lived, which was the priestess's rooms, which were that princely shrine of cosmic order, they tracked the passage of the moon. And that was the observatories, the network of observatories that she built across Sumer. So I pose a question to you. Was she a scientist? And my answer is yes, she was. But some philosophers disagree because they say science did not begin until the ancient Greeks. So I disagree with them, but this is up to you to make your own call. Excuse me, that's the cat. We'll get her down.
Not a remote event if you don't have a cat.
If you don't have a cat. Imhotep, we've discussed, and Hedwana. Aganichi was the sister or wife of Sesostris, the pharaoh of Egypt, and she actually developed equations or wrote down the orbits of the planets in hieroglyphics, which is no mean trick. She was an astronomer. And I put here, just for fun, the world's first chemist. I can't pronounce the name, but she was the first. She is known as the world's first chemist. She was an alchemist. She ran the perfume organization for the king in Sumer. And that was a big deal because perfume was part of their rituals. There is a plate, a cuneiform tablet. It's called Plimpton 322, which means it's number 322 in the Plimpton collection. It's dated around 1800 BCE, and it actually is from Babylon, and it contains triplets, A, B, C, which were later called the Pythagorean theorem. They had it back then in 1800 BCE. They had the Pythagorean theorem. Because here is A, the column, here's B, the column, and here's C, the column. And they had written them down for use. Now, after 1200, many things changed. The Bronze Age came to an end and the Iron Age started. Massive migrations of people occurred, and it was very chaotic. Not much happened in science. But by this time, they did have a lunisolar, which is a combination of a lunar calendar and a solar calendar, and a solar calendar. The solar calendar was used by Egypt. I approve of the Egyptian calendar because this is how they did it. They had each month of 30 days. 12 months added up to 360 days, but there are 365 days in a year. So there were 5 days left over. And they said, we're going to work hard through the year. And on those 5 days, everybody in Egypt is going to party. And I think that's wonderful. I like that calendar. I think we ought to do that here. Have 5 days of parties at the end of the year. By the time we get to ancient Greece, Homer actually had astronomy in the Iliad. He mentions these particular celestial objects: constellations, star clusters, Sirius the dog star constellation. And so I don't call him an astronomer. He wasn't. He was a poet, wonderful poet, but he did know about astronomy. And then about a little bit later was Anaximander, who tried to describe the universe as a cylindrical earth floating free in the center of the cosmos. So it just stood there unsupported in the center of the universe. This is his map of the world, Anaximander. Europe, Asia, and Libya, and then he shows where he is. He tried to observe and explain different aspects of the universe. And according to him, nature is ruled by laws. This is where the philosophers say science began. Instead of ruled by miracles, it's ruled by laws. So I think science began before this. It doesn't have to be, doesn't require miracles even before this, but any rate.
So Dr. Howard, we do have a question. Would you qualify Homer as legendary?
No. I've read Homer when I took ancient Greek. No. He was real. Humans came, according to Anaximander, humans came from warmed up water and earth as fish, like animals. And the animals came forth out of the warmed up water and earth and burst open, and men and women came out. That is where he thinks men and women came from. To me, that's not very scientific, but okay. That was his approach. Thales of Miletus lived, and he was an astronomer. He lived in, I can't see underneath it, but he lived in, what does it say? Underneath Thales of Miletus. He lived and predicted a solar eclipse on the 28th of May, 585. And during that day, there was a battle going on between the Medians and the Lydians, and the solar eclipse stopped the battle. They made peace and went home friends. He was an astronomer, but he got his astronomy from Egypt. And Egypt got their astronomy from Mesopotamia, from Sumer and Babylon. He also said he wanted to replace the miracle causes with the laws of nature. And the Greeks eventually came to believe that if you're going to obtain knowledge, the only way you're going to get it is to deduce it, deduction. We don't believe that anymore, but that's what they believed. Pythagoras of the Pythagorean theorem. He founded a sect where philosophy, religion, art, and mysticism all fused together. And in his philosophy, that's the cat making the noise. Number was the first cause of existence. And he also believed in the transmigration of souls, which means a person can be changed into an aardvark on the next iteration of the great wheel. That's the cat. Sorry about that. His wife, Theano, was also a philosopher. She was a member of the sect, and she wrote several treatises, but the one that she's most well known for is the Golden Mean. You may have heard of the Golden Mean. The golden ratio is A plus B is to A as A is to B. That's the golden ratio. It's 1.618 ... It's a non-repeating infinite number. That's the golden ratio. And actually, it's still around today. The golden mean spiral is based on rectangles, golden rectangles. And the black line marks out the spiral. And you find it today in a staircase that I would not go up, but in a shell, in a hurricane, and in a galaxy. This is M51. In the center of M51, you find the golden spiral. Empedocles was not an astronomer either. I stick in a few just because they're interesting. He believed in evolution and survival of the fittest, which I did not realize until I looked this up, that actually before Darwin, there were other people who believed in evolution. And he's the one who's responsible for earth, fire, water, and air as the four elements that make up everything in the world. That's his responsibility. Plato actually was not an astronomer, but in two of his writings, Timaeus and the Republic, they contained his astronomical beliefs. He believed in a two-sphere model, which had a sphere, and then the sphere of the stars as a faraway sphere. He also believed that retrograde motion, they knew about retrograde motion of the planets, was combinations of uniform circular motions on a spherical Earth. That is epicycles. So long before Kepler did epicycles and other people did epicycles, Plato was doing epicycles. But Eudoxus, who was a famous mathematician, second only to Archimedes in math, was the first one to attempt a mathematical description of the planets. And you see the retrograde motion of the planet, and watch as it slows down right here. He actually shows the reason for the slowing down during the retrograde motion and the speeding up of the retrograde motion by using a series of spheres. He had 37 of them, I believe, and this only shows 2. But this is how he explained retrograde motion. Callippus added 7 more spheres to his 27, not 37, 27 original circles. He added 7 more, improved upon it. And by this time in Greece, they had the Metonic 19-year calendar cycle. If you know what the Metonic 19-year calendar cycle is, it's 19 years, and in the 19 years, the time of New Year will repeat 19 years later on the same day. That's the Metonic cycle. And that the Greeks thought this was so valuable that the location on the series of 1 to 19, they called the golden number, and would post it on a cylinder in Rome, in Athens, in gold. It was called the golden number. Callippus said, we don't need 19 years, we need 76 years. And it was an improvement. It actually was a little better guess at the proper length of the solar year, but it stayed around for a while. Ptolemy even quoted it, but it died out. It didn't become as acceptable as the Metonic 19-year calendar cycle became. The golden number is used to help set the date of Easter. And just for fun, again, a mathematician, not an astronomer, Euclid lived in Alexandria, Egypt. And this is a picture of a scrap of his book, one of his books on geometry from the early Middle Ages. This isn't actually his actual writings, but it's a later picture. And Euclid, it's one of the most successful mathematical books ever written because we still use it today. Aristarchus said, the sun is at the center, not the earth, and the earth revolves around the sun, takes a year to do that, and it rotates on its axis once a day. He put this forth, and some people believed him, most people did not. He said this is the way it is, but unfortunately it didn't become standard for the world until much later. Archimedes was the most famous mathematician of antiquity, and he's the one who studied many things, among which were levers. And with a lever, he said, give me a place to stand on and I will move the earth. He anticipated calculus. He did almost made it to calculus in his mathematics. There is a spiral called the Archimedes spiral, and that's one arm of the spiral. Looks like that. It's pretty. He's the first known Greek to have recorded multiple solstice dates, but he's not the only person who did that, but he's the first known Greek to do it. So in Greek, he wrote down multiple solstice dates in successive years. And he built planetaria or orreries. And I point out that they think he may have had something to do with the Antikythera, which was found off the island of Antikythera in a sunken Roman ship. And it was torn apart by being under water for 2,000 years. But it's a hand-operated orrery, an analog computer. 37, they x-rayed it and tried to reconstruct it. It's got 37 meshing bronze gears, enabling it to follow the movements of the moon and the sun. That it's a remarkable device. And it shows that the Greeks did more than just theorize. They actually constructed something. And they think Archimedes may have been the only one capable of doing this, but they don't know. He didn't write that he did it. And there's no record from the ship, the sunken ship, of where they got it. They're going back to the ship to look for more pieces. They think the pieces for the planets are missing. And they're going to look near the sunken ship to find those. They were going to do that around 2019. Archimedes did something very clever. He said, how much sand can the universe hold? Grains of sand are small. So he counted them up somehow based on myriads, which is 10,000 in Greek. And he used a myriad of myriads, 100 million, and concluded that the number of grains of sand is 8 times 10 to the 63rd. That's remarkable. For the number of grains of sand that would fill the universe. given that the grain of sand is bigger than an atom, we have between 10 to the 78 and 10 to the 82 atoms in the universe. So he was actually doing pretty well for grains of sand. Other ancient Greeks, Aglaonice was an astronomer who predicted eclipses, and she bragged about it. So she was thought of as a braggart, and maybe she could predict an eclipse, but so what? So could other people. But she was in Thessaly, and they called them the witches of Thessaly, the women with her who predicted eclipses. Eratosthenes is the one who measured the circumference of the Earth and its axial tilt. He worked in Alexandria, Egypt, and the chief librarian at the Great Library in Alexandria. And if you don't know about the Great Library in Alexandria, look it up, because it was one of the great treasures of the earth. The rule was that if you brought a book to the library, you had to leave the book and could take away only a copy. So the Egyptians, the Alexandrians, wanted for their library the Greek plays, all the Greek plays. There were hundreds of them. And the Greeks didn't want to give them up. So the Pharaoh of Egypt promised that he would return the originals if they would send them to him. So they sent the original Greek plays to the library, and he, of course, reneged on the deal and did not return them to the Greeks. So when the library was finally destroyed, burned up, we lost. That's why we have only a few Greek plays. We lost hundreds. We lost the Bible, the original copies of the Bible. We lost the original Greek plays. We lost the original Euclid. Only copies existed scattered around the Middle East. It was a great tragedy in history, was the destruction of the treasure of the world at Alexandria. Hipparchus, it's Hipparchus's fault that we have magnitudes. And he built a star catalog, and a -6, he did from -1 to 6, and -6 was fainter than -1. So it's his fault that we do it that way in astronomy. He discovered or calculated the precession of the equinoxes, which is pretty good. He's known as the father of trigonometry. Mathematics and astronomy went together. They were essentially the same field. But by now, we have a spherical Earth, a rotating Earth, a heliocentric universe, if you believe that minority group. We can predict eclipses. We have lunar, lunisolar, and solar calendars, and a precession of the equinoxes. I point out, in case you didn't know it, Cleopatra studied astronomy. She studied other things as well and spoke 8 languages. But she is responsible. The Romans had a very messy calendar. Their calendar just didn't work. They couldn't keep the years straight or the months. And she's the one who told Julius Caesar, we can straighten out your calendar. And she lent to him the court astronomer for her court, who went with Julius Caesar to create a calendar for the Romans that eventually, not immediately, but eventually became the Julian calendar. Ptolemy lived in Alexandria and worked at the great library there. It hadn't been burned up yet. He wrote 13 books called the Greatest, or the Almagest, and they predicted the positions of the planets. That was very important. He wrote other books, and his book on optics shows a table of refraction from air to water. That's fascinating to me that he actually calculated refraction and table of refraction from air to water. It uses the sine of the angle, and that was pretty good. The picture is a Arabic translation of 2 pages from Ptolemy. Hypatia. Her name is pronounced Hypatia because she was Greek. She was the philosopher at the great library at Alexandria. She did a lot. She taught, she invented, she wrote, she was an astronomer. And I mentioned that there is a DVD called Agora. It is in libraries. It's available from Amazon. And it is one of the best short films on her life that I've ever seen. They do a very good job of describing Alexandria at that time when she lived and what she did. Historians say she invented the astrolabe. This is not true, because astrolabes were known by much earlier, hundreds of years earlier. They knew about astrolabes. That was the Antikythera that was found, the 37 bronze gears. But she did invent the hydrometer, a method for measuring specific gravity of water. And she did build astrolabes. She constructed them. She knew how to do it, but she didn't invent it. That's an error in history books. And some people call her the first astronomer or the first scientist in human history, and that's also incorrect. She wasn't. Important lady, but she wasn't the first. Raphael, who painted the School of Athens, thought she was so important that he put one woman in his painting, and we think that's her right there. There's Archimedes, there's Plato, and there's Aristotle. The School of Athens. She wrote several books, all of which have been destroyed in the destruction of the library, but we know that she wrote them because they're mentioned in letters from students to her and her to students around the Mediterranean. All her students wrote to her throughout their lives from around the Mediterranean. They came to study with her. She was known for speaking her mind. And I'm going to quote for you something she said. Fables should be taught as fables, myths as myths, and miracles as poetic fancies. To teach superstitions as truths is a most terrible thing. The child mind accepts them and believes them, and only through great pain and perhaps tragedy can he in after years be relieved of them. In fact, men will fight for a superstition quite as quickly as for a living truth, often more so, since a superstition is so intangible that you cannot get at it to refute it. But truth is a point of view, and so is changeable. This was 2,000 years ago that she wrote this, and it's still true today. She also said, and this I'd love you to memorize, reserve your right to think, for even to think wrongly is better than not to think at all. Now she was, as I said, spoke her mind. She was a pagan in Alexandria, which had pagans, Romans, Christians, and Jews, lived as different groups in Alexandria. Bishop Cyril of Alexandria was head of the Christians, and he did not approve of her. And he incited a group of monks who caught her from her chariot as she drove through the marketplace. Agora. Agora means marketplace in Greek. And grabbed her from her chariot and tore her skin to peeled her to death with oyster shells. And that is how she died. She died for her right to think. And because she died for her right to think, I'd like to believe we don't do that anymore. Dr. Jerome Amoudi, on December 27, 1981, was executed by Iranian Revolutionary Guard. She was a meteorologist who was a woman who dared to be a scientist, and she was executed for that. Fortunately, Malala is still with us. But I like to dedicate these talks to Mahmoudi in her honor. Now, the astronomy moved into the sphere of Islam in the Dark Ages. In fact, the oldest university in the world, I can't pronounce it, but you see it there, right here. I don't know how to pronounce it in Arabic. But Fatima had lots of money, and she decided to endow a university. This is the oldest university in the world, and it operates today. It is the oldest continuously operating university in the world. It gives degrees and majors, and even when it was founded, it had astrolabes and sand clocks. It's in Fez, Morocco. That's the oldest university in the world. Maryam handcrafted astrolabes. She lived in Baghdad. Islam in Baghdad at the House of Wisdom in the early 9th century. The House of Wisdom was a scholars' academy where people came all over to with the scientists and philosophers at the House of Wisdom. Muhammad was the head of astronomy there. He was a Persian polymath. And Baghdad and Damascus became the centers of scholarship for the world at that time. In the late 10th century, an Egyptian astronomer found problems in Ptolemy and said Ptolemy did the wobble, the precession, wrong. And he contradicted this finding by calculating that the wobble should be 1 degree every 70¼ years. Now, Muhammad, the one who was head of astronomy at the House of Wisdom, was a polymath who did amazing things. He was the father of algebra, solved quadratic equations. Algebra is the title of his book. He introduced the decimal positional number system. It came from India, but he brought it from India to the Western world. He revised Ptolemy's geography book by listing the latitude and longitude of various cities and locations, which Ptolemy did not do. And he also constructed an ephemeris, tables for the movements of the sun, that would predict the movements of the sun and the moon and the planets for Baghdad. He did it for Baghdad, an ephemeris. So he was a polymath, a genius in mathematics. Other scholars, Al-Battani wrote an ephemeris, and that particular ephemeris was frequently cited by Copernicus in Copernicus's book. So it was used by the prediction, the book of astronomical tables was used by European astronomers. He actually determined the length of the solar year that is only 2 minutes and 22 seconds off. Pretty good. Fatima of Madrid in 1000 CE published corrections from Fatima, and they were based on the ephemeris built by the Persian polymath, and she corrected them, updated them, and put them in Madrid rather than Baghdad. So she actually concocted an ephemeris, predict the positions of the sun, moon, and planets. which was used by Europeans. And we're now up to 1000 CE, and I'm going to end with Hildegard, who was the 11th century scholar leader, a genius, musician, writer, mystic, healer, artist. She wrote many, many books. She was a Benedictine nun who lived in Bingen on Rhine in Germany, northern Germany, and she wrote a book on the natural world. That was a book on physics. And she also wrote a book on herbs and spices. She believed in the power of herbs and spices, and especially the power of cinnamon. And you can find on the web Hildegard's Cookies of Joy. That's what they're called. So you don't need to write down the description, the menu. Hildegard's Cookies of Joy. And they will calm every bitterness of heart and mind if you eat one. They're very nice. They're rather small, but they're very tasty. And if I were doing this in person, I would give you one. But I haven't figured out a way to get cookies through the net yet. Hildegard's Cookies of Joy. She also wrote Gregorian chants. And this is a page from one of her Gregorian chants. I have 8 CDs of her chants recorded. And if you are interested in her music, the National Cathedral in Washington, D.C. in the year 2000 performed her music all day in her honor, 1,000 years later after her death. But if you buy one, please get one without an orchestral accompaniment. Some people recorded the beautiful music and put in an orchestra. Gregorian chants are meant to be chanted and sung without an orchestra. So please don't get an orchestra with the CDs if you get them. She also illuminated psalters, prayer books, Bibles, and my favorite is the one on the right, which reminds me of falling stars. And these are called illuminations. The nuns had a room full of people who illuminated with paint the Bible and the prayer books. The nuns did it, and so did the men. Her science, she wrote a book on the physical world. The stars gravitate around the sun, just as in the same way that the earth attracts the creatures which inhabit it. That's universal gravitation, long before Newton. She didn't have a formula for it, but she had the concept that gravity is universal. She wasn't perfect. She did say that stars are not immovable, but transverse the universe. That's good. Okay. But she also said a precious gem will heal the body if taken to bed. Now, I don't happen to have a bunch of diamonds so that I can test this out. I don't have a big cadre, a chest of diamonds to test to see if it would cure me of any spiritual defects. So I must have my spiritual defects that I was born with. And Nina Cassian was a national poet of Romania. And I'm going to end with my definition of a scientist or an astronomer in this case. I've stitched my dress with continents, bound the equator round my waist. I waltz to a steady rhythm, bending slightly. I can't stop my arms plunging into galaxies gloved to adhesive gold. I carry on my arms a star's vaccine. With such greedy sights, my eyelids flutter in the breeze like a strange enthusiastic plant. No one fears me except error, who is everywhere. And I think that is a beautiful example of what an astronomer or a scientist is. So if you don't know who Helen Keller is, look her up. She was a grand lady of the 20th century, not an astronomer, but she said no pessimist ever discovered the secrets of the stars or sailed to an uncharted land or opened a new heaven to the human spirit. And I thank you for listening, because we've now covered 3,000 years of history of astronomy. And that's the end. So I can stop sharing the screen if that's okay.
That's good.
There we go.
All right. Well, thank you very much. We'll let people have a couple of minutes to see if they have any questions that they would like answered. You talk about observatories and that there were networks of observatories in the ancient world.
Yes.
So one assumes they did not have telescopes.
Right.
So how and what did they observe?
The moon. They were observing the phases of the moon, and they would set up a sighting, a sight. Not anything with a lens or glass, but a sight, a tube that would allow you to time when the moon was going to cross over. The equivalent of a transit, if you will. But they weren't like our transits today. They were very limited in what they could do. And it was for observing the moon and the planets, but mainly the moon.
Excellent. So the moon was probably one of the most important things that they were observing. One observes, since they were you talk about eclipses, and that they were able to predict eclipses quite some time ago.
Yes. And I don't know how they figured it out, but they did. I don't know the method they used. But if you watch enough of the motions and you get the orbit of the moon down to your significance of your time, and you get the orbit of the Earth down to your significance of your time, you can calculate when the eclipses will occur. And that's what they did.
So Kenneth also wants to thank you for the talk and would love to see more of your cat, actually.
Well, she's now underneath the computer.
Very well.
Thank goodness.
So were there any other examples of the I can't even say it, Antikythera?
Antikythera, that's the only one. And I can also show you, I forgot to show you, I have a cuneiform disc. This is from Dr. Lulu, who was a doctor, MD, physician, and it's what he would put in his pocket to carry around, and it has I think 12 different prescriptions for boils. Boils seem to be a big problem in those days for curing boils. And this is what it looks like. It's the size of a cell phone. It's not humongous. So I thought I'd show you what one actually looked like.
Definitely doesn't look like something you could just stick in a pocket, though.
Yes, it is.
Yeah, a big pocket.
And it's written on both sides. And it's big enough to fit in my pocket. Small enough to fit in my pocket. Yes.
You have to have a strong pocket, though.
Oh, you'd have to have a strong pocket. It's not light. But if you had a fold of a robe, you could put it in the fold of your robe with no trouble at all. They're rather unique. This is Dr. Lulu.
So one final question before we go, unless somebody else is going to enter something in the comments. You talked a lot about sort of the relationship of different fields, especially math and astronomy. Could you talk a little bit about the relationship between astrology and astronomy in the early days?
Actually, there was no relationship. Astrology did not come into use as we know it today into common use until about 2,000 or 1,000 years after Enheduanna. What they had in her time were omen tablets, and omen tablets are not astrology. They are what historians of theology called if-then tablets. If such and such happens, then such and such will happen. My favorite omen tablet says, if a woman shall give birth to an elephant, then the land will be laid waste. To me, that makes perfect sense. So yes, that's my favorite omen tablet. But there is no relation in early days between astrology, as we think of it as the stars determining your life. They had many things for omens. The spiraling of a smoke from a sacrifice was one of the first. Uh, if you burn your sacrifice, how the smoke spiraled up, or the behavior of a flock of birds at the gate of the city. That was an omen. So they had that kind of thing, but they didn't have astrology as we know it today, the predicting your life based on the positions of the planets. That came much later.
Okay. Any other parting words of wisdom for us, Dr. Howard?
Well, I think I'd like to think of the fact that these early astronomers actually progressed the field quite a lot. And astronomy and mathematics marched together until the mid 1800s. That was when the modern sciences took off. Physics broke off, chemistry broke off, and it was about that time that mathematics would separate from astronomy. The early mathematicians were astronomers, like Newton. He was not a physicist, he was a mathematician, and he was an astronomer. We call him a physicist, but physics didn't break apart until the 1800s, break out as its own science. So I'd like to think of astronomy and mathematics as the history of science up until recent days.
Excellent. Well, and they are still linked pretty closely.
Yes. Yes.
And exciting times are ahead of us with modern astronomy.
Yes.
Especially with hopefully the Webb telescope will show us new and wonderful things in the near future.
It's meeting all of its marks. It had 301, I think, single point failures, and every single one of them has passed so far.
So far, so good. Let's hope it stays that way. Well,
Yes.
I want to thank you again, Dr. Howard, for talking with us today. I want to thank everybody for watching, and we hope you stay tuned, that you'll come to some future events that we'll have online and hopefully soon in person. We do actually have a walk coming up. We're doing some co-branding events with Walk Arlington and some other folks, Bike Arlington, coming up. So, tune in to visit our webpage, tune into our Facebook page, check us out. We will be having more events, and more exciting, we will be hopefully involved with the reopening of the Arlington Planetarium this fall with a new projection system. So until then, take care, and we will see you soon.